Hi, today we're going to talk about the two types of formulas that we have. We have empirical and molecular formula. In addition to structural formula, these are the three types of formulas that you're going to have to know for the reagents. So we're going to use an example of glucose right now. If you look at glucose, it's drawn out, or it's arranged like this. This is considered the structural formula. Now the molecular formula is slightly different. So structural formula is one thing. That's the way that it looks, which molecule or which atom every atom is bonded to. The molecular formula is something different. The molecular formula is what we use to calculate the gram formula mass. For this one, glucose, it's C6H12O6. If you look right here, we got 1, 2, 3, 4, 5, 6 carbons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And we have 1, 2, 3, 4, 5, 6 oxygens. C6H12O6. Now when we do the empirical formula, all this means is it is the most simplified version of the molecular formula. So if we look at this molecular formula, C6H12O6, how many times can we divide this? Or what can we divide it by to get the lowest common or the lowest numbers? Take 6, take 12, take 6, they all have 6 in common. When we divide this, we're going to have CH2O. And that is the empirical formula for glucose. Now let's look at something else. We have two other examples. We have carbon dioxide, which is CO2, and water, which is H2O. So when we look at CO2, this is the molecular formula. Now when we do the empirical formula, you will just remember that there is one carbon here. So one carbon and 2 oxygens. You're not going to be able to divide this by anything to make it any simpler. So the empirical formula for carbon dioxide is also CO2. Now let's look at water. H2O, this is molecular formula. This is the structural formula with 1 oxygen and 2 hydrogens. And likewise, just like the case with carbon dioxide, you can't divide this by anything to simplify it. So the empirical formula, my bad, is H2O. Simple, right? Thank you.